Today I'll talk about analyzing functions using differentiation. So first let's start with a really easy function. F of x is equal to x squared. Wow, it's bright. I'll turn it down a little. That's better. So f of x is equal to x squared. And yeah, I'm sorry for the visibility here. It's night, which is why it's bad visibility. So yeah, f of x is equal to x squared. So just in this form, already we know it's x and y intercepts. Like that's all we can know at this point. So now we can actually differentiate this to get f prime of x, which is equal to 2x. So now with the differentiation, we can with the derivative, the first derivative, we can do something cool. We can find the maximums and minimums of the function. Why? Because in the maximum or a minimum of a function, the tangent line will always be 0. So we just have to find a place where the slope or the first derivative is equal to 0. And we can find the place easily because in this case, it's when x is equal to 0. So now we know like that we have either a minimum or a maximum at x is equal to 0, and we can plug this in to find like the value of that minimum or maximum. But to find out like whether it is a minimum or maximum, we take the second derivative, which is equal to 2. So now if the second derivative is positive, that means the graph is concave up at that point, so it would be a minimum. But if it's negative, then the graph is concave down at that point, so it's a maximum. So in this case it's positive, so this is a minimum. So if we take the second derivative, we can get the concavity of the graph as well, which is really important. Now lastly, if you want something called the point of inflection, we'll have to look at a different example because x squared does not have a point of inflection. However, x cubed does. So for the point of inflection, we'll have to take the second derivative again, and at the point of inflection, this mysterious point of inflection, the second derivative is equal to 0. So for these points of inflection, what happens is there is a change in the concavity of the graph. So that means that in this case it goes from concave down to concave up, and that is a point of inflection, which is why at x equal to 0 there is a point of inflection. So these are how you analyze a function using differentiation. Thank you.